cylinder sensors. See this stuff? Reed switches are very inexpensive, but the wires are very flimsy. They can get contaminated. Hall effect switches are a little better, but they have their own sets of problem with drift. And usually they're not short circuit protected or reverse polarity protected. So we got to be careful with Hall effect. There's other choices from different manufacturers out there that are a little more robust. You can guard them and protect them, but these things fail with regularity. You can see why. It's hostile, just a bad place. Oil, contamination, heat, slag, the same effects. I also found an interesting one. We have a customer throwing sensors away like crazy. If you're doing pneumatic sensing and you have a lot of fine mist and a lot of debris, fine debris, it'll find itself behind the sensor element and wedge itself between the wall, the aluminum wall of the cylinder. It'll block the Gauss from being sensed by the sensor, and they think it's bad. They pitch it. So put another one on, it starts working because you've removed all the dust. And that's something to be very careful of. You need to wrap and protect it with these different covering products that are out there. This is real, and this is repeated, I swear, weekly. And this is a real situation. Working with a large Tier 1 in Kentucky, we are called in for a very specific reason. It was paradigm reversal. We have a new plant manager here that's very much thinking outside the box. Between January 1 and April 27th, there were 117 minutes of downtime, and their value for downtime is $422 a minute. So if we annualize that out, that's just what they knew they could capture that was attributable to sensors and connectivity. And ironically, it's not robotics or hydraulics or pneumatics or the machine bed that goes bad. It's vulnerable devices like sensors that get bombarded that fail with regularity. So that's $148,000 a year in one cell, making a truck frame, portion of a truck frame. It's a mess. 148 grand, and there's 20 cells in this plant, so it's easy to calculate what the cost is going to be for unplanned machine downtime. And God knows what the cost was on material because they're getting it all out of a vending machine. And there are 7 variants of an 18mm switch being used in all different locations. No commonality. They're just throwing whatever in. L brackets and plastic brackets. So, there's your first quarter downtime. And there's our cost per minute. And these came right from the quality manager. Here's what happened. And I just checked with these folks, been checking with them monthly. Since last April, one sensor was destroyed when a frame component wiped out the whole sensor point, the whole system. So in essence, when you take the $11,000 cost of upgrading those 22 sensor points with a standard 18mm product, the right bunkering, protection, the right cable. We also threw lighted cables in there so the maintenance people knew there was power and status. They could look at it real quickly inside the cell. It's like these things are like caves, you know, when you look inside and they want to be able to look at things very quickly. This is what happened. And that's the savings right now. So we've done this for a year. In the sister plant in California, we're doing the same thing. It's repeating itself. We've done it for other people in other states. It's totally repeatable. It's amazing. So this is what we found going in one location. Here's what we did after. We have a lot of loading impact. This particular sensor is in the bottom of a cell, so humans stand on it and they drop stuff on it. And this is before the wiring was also protected. I ran out of a coated product during the retrofit, so we put an uncoated product in, but it's still working because of the bunkering. Everything's totally guarded. And it's so robust, you're just probably never replace the sensor again, I don't think. You can see the hostility. A simple L bracket, everything's exposed, nothing's guarded. And here's what we did after. A prox mounting situation that repels weld slag, gives you corner protection, heat sink properties, L-shaped lighted cables to follow the exit geometry properly, covered with medical grade silicone, covered in a silicone wrap that fuses to the tube itself. You can put a torch in that stuff and it won't burn, non-adhesive. It's a molecularly self-bonding product. Pretty cool. Another one, and that's what it looks like even today. You go back there, it's a little brown in a couple areas, but it's just like it was last April. So the paradigm reversal is, instead of hanging an inductive procs out in the middle of nowhere, these are generally rated from -20 to +70 degrees Celsius. They're not meant to be banged on. They're non-contact devices, pounded, covered with slag, exposed to heat, burst temperatures up over 1200 degrees often. It's a bunker, quick change mount that allows you to position your cable any way you want it, guards the whole sensor, TPE type cables. I don't know if you've heard of thermoplastic elastomer. It takes PUR another notch. It's very flexible and easy for maintenance people to work with, but flex heat just takes it a notch of performance way up above PUR. Just common sense. Right sensor. If you need a steel face product, great. If you need a coated product to resist weld slag, great. But it's the right sensor, the right bunker, TPE, connectivity, seal it up, same thing. If you can get away with a photo in a weld cell, do it, but we can get them to work effectively. Sometimes you just have to use them. Pneumatic clamp sensors, upgrade. Look at root cause of failure. After we get done, what we do, we work with customers. Any number of companies have so much redundancy in stock that's not even being used. There's hundreds of thousands of dollars in some of these places. We need to get rid of it. We'll, as a company, we'll even provide change out sometimes just to get it down to a handful of common components. It's crazy to have drawers and drawers and drawers full of obsolete material. It just leads to more problems when people put the wrong sensor in the wrong spot. Get rid of it. So, the last part, when you're building your new cell, what do we get as a sensor provider out of all of this that people say you must be out of your mind to want to reduce consumption? Well, the whole point is if we don't do it, somebody else is going to do it. But the second part is I always ask the customer to earn the right to sell them, and then I ask for a specification after. When you get your new cell, please give us the opportunity to work with your weld cell maker so we can not get in this boat again. We just avoid this right from the beginning. And it's worth a couple of bucks more to put all this in. It just it performs. It's absolute. And that's it. Simple. It's common sense. Best advice I have for you. So,